they have the same format. So if I gave you an exponential, might look something like that, right? And the graph has it looks something like this, right? Or we could do something like this. Correct? Which is still an exponential, but the value is
decrease
less than 1 versus the value greater than 1, right? That will prove big with geometric series and sequences. So, you on board with that?
Can you wrap my head around why the red line goes like that?
Just plug in x. Plug x is 1 in. It's 3 over 2, right?
Sure.
Which is here.
Yeah.
Now plug 2 in. You have 1/4, 3/4. So it's actually going.
Underneath you had negative 1,
Mm-hmm.
2, 2, 6.
Correct. Okay. So exponential growth versus exponential decay, right? Okay. A geometric sequence is very similar. What's the difference between the two?
this one like steps.
Yeah, why? What numbers are we plugging in here?
Everything.
Do you know what those are called in math?
Integers.
Integers.
Ooh.
What are those called?
Variable.
Exponents.
Number systems. What are they called?
Rational numbers.
Okay, we're naming them now. We're still not the right one. What are we studying in calculus?
Real numbers.
Real numbers. Okay, so you have a real number, which includes everything, solid line, versus geometric sequence, which if you graph this.
Oh, so real number includes decimals.
Yeah.
Versus 1.
Correct. So if we graph a sequence, it's going to look like that, correct? All right. So that's a geometric sequence, and we can do the same thing. In general, that is the format for a geometric sequence. So if you see the term geometric, it means multiply. See, it's C times R to the n. What do you do when you calculate area? You multiply, right? If you see the word arithmetic sequence, it means add. I think we went over that Friday. Arithmetic sequence, arithmetic, is add each term. This is multiply each term.
Why? What are we even solving when we do that?
All right, so the question is, where does that sequence converge and diverge?
0 and 3.
No, it's 3.
For what value of
Oh,
R?
you're right.
Well, no, that's when they intersect.
So this black one, if you look at the graph, would you say that it diverges or converges?
Diverges.
Okay, so you are correct, black diverges. Goes to infinity, right? How about the red?
It
Converges.
converges to zero, right?
Or is it to 1?
What's a zero?
Yeah, what's the lower bound? We're gonna talk about lower bounds.
So it'd be 0.
Basically, it would be a horizontal asymptote.
I think it's zero. Because you'd have like 3 times 1 over infinity. So you have something divided by infinity.
So this would converge to 0. Right. Yeah, you just did a limit, that's all you did, right? That's called the nth term test, we'll talk about that tomorrow.
Discuss.
Okay. So what do you notice about the values of R there?
They're small.
Okay, what else?
What's R? What is the
R. R. So those are the values of R, okay. So, can we make a determination about the value of R, whether a sequence converges or diverges?
Yeah.
If it's less than 1,
Okay. So if R is less than 1, sequence converges.
And this is just for exponentials, right? Is what we're saying.
Geometric sequences, yeah, very specific.
So then is that what the
Okay, what if R is greater than 1?
It
Diverges.
Diverges. Okay, what if R is 1?
Does it exist? Or do we have to use a different
No, it just
test?
needs a constant, it'd be 3. If R was 1,
Okay.
Is this the same as the ratio test on the paper?
No,
No?
we're not there yet.
if R was 1, it converged to 3, but I don't know what 3 is. Is 3C?
Yeah. Center.
So if the value is just 3, does that converge or diverge?
I don't know. It doesn't move, so it
It's
doesn't slow.
static.
Yeah, so does
It's
that
a
mean it
line.
converges or diverges?
It does not.
It doesn't do either.
It does, one or the other.
Wait, it diverges on 3.
Because it doesn't move?
3 goes to infinity.
Okay.
Does the y value converge to a number?
Yeah.
Yes.
Correct.
Okay.
So at r equals 1, in fact, it converges. Okay. What if I throw negatives at you?
Diverge, yeah?
It'll hurt our brain?
Wait, what do you mean for a negative?
What if r is negative?
R is negative?
Well, then you
Less
can
than
use the
one.
same rule.
Then it would flip-flop.
Oh, we have to do the stupid, if the exponent is even, it's exponent flop. But then you're looking.
No, isn't just do what your kidney said, and just flip it. So if R is greater than -1, it converges, and if R is less than -1, it diverges.
I still think it converges because it's less than 1.
Yeah.
But it changes depending on if the exponent's even.
Should I just leave you hanging on that one?
Probably not. It
No.
converges.
I'd rather we
Doesn't it
did.
go up and down though? Because like the result would either be negative or positive, and if the exponent's even or odd. So it's gonna fluctuate, and then it's just gonna be 0. It converges to 0 every time. Finally.
Converges.
Okay, so what you're saying, Montaigne, is this converges to 0?
If it's negative.
Oh, you're talking negative. Do you agree with him?
If I'm right, I'm a little.
I mean, it makes sense. It makes sense what he's saying.
So if r is between,
Negative infinity and 0, it converges to 0 every time.
Or would it be the case of,
80% of the time it works, and 50% of the time.
or would it be the case of 1 where it converges at the center? Oh, but no, because the center's not necessarily negative.
So am I summarizing what you're saying, right?
Yeah.
Okay, so which one converges?
They both converge. Less than A1, or greater than A1, and less than 0 converges to center. The other one converges to 0.
Sure.
I hope so.
If R is less than or equal to -1, so if you plug -2 in here,
Yeah. There's going to be one up above that's positive, and then one that's negative, positive, negative, and it's going to be back and forth until it approaches 0.
No, because a negative exponent, if it's integer or real numbers, it's going to create a fraction.
it does. It gets
No, we're talking about R, not N.
R.
Oh, right.
Okay. So if R is to the first power, you get a negative, right?
Yeah.
If R is to the second, you get a positive.
That's
Now, are you going closer to the X or farther away?
Farther away. Oh!
That's screwy.
Dang it.
Divergence.
Man, I thought I was a genius for a second.
I mean, the reasoning is solid.
So, that's one thing that we'll want to make sure that we know. And so this is a sequence. What you have to keep in mind right now is we're talking about sequences. This sheet that I gave you is for series. So when we add
Oh.
these together, what happens? Okay? So we'll get to that. But now you know what a geometric sequence is. Okay? And when they converge and diverge. Makes you think though, doesn't it?
So for that first one, we have to change it? Because we could say less than 1, we're just
Yeah,
just
that's
get a
true.
0 to 1?
R is less than 1 and greater than 0.
Good call. Okay.
So at 0, would it make a difference if R is 0?
If R is 0,
It's just going to be 0.
probably the function is 0.
Yeah.
Does that converge?
Yeah.
Yeah. And in fact, it converges to the same thing as,
Yeah.
Wouldn't a negative fraction be different than a negative whole number?
yeah.
Because a negative fraction would make those dots come closer, so it converge at 0. But that's not, you could have,
Yeah, -1/2 fits in here. Convergence. Because it gets closer.
Yeah, well, I was thinking like maybe 3/2, but that's, yeah.
Oh, like, okay, gotcha. Okay, let's move on. Okay, bounding. Okay. You've already seen it a little bit, but here's a more formal definition. We can have a sequence. And if you write it properly, it's a set of numbers. So it's a sequence, but that just outputs a set of different numbers, right? Bounded from above. You could probably describe this already. What would that mean?
Horizontal asymptote above the equation.
Exactly. If you're in a function,
Right.
okay? Now, if you're in a sequence, it's now bounded.
It converges on a
Okay,
number.
so functions have horizontal asymptotes. Sequences are bounded.
Okay.
Okay? See the language difference?
Wait,
Because
so
a function,
Functions have horizontal asymptotes,
because it's all real numbers.
right? Sequences are
Because they're all
bounded.
numbers.
Okay, it's just, it's the same concept.
Is
So
that
is the
'cause-
difference like
Small.
it's always approaching that for a function, but on an integer it just like never crosses?
Well, it's the same thing, they never cross that value.
Do you ever connect the dots for a sequence, or is it always just dots?
No, that's, he said that's what
That
the
would
series
be-
are.
So you can analyze a sequence using a function. The limit has to have a function attached to it. So we turn this into a function to analyze the limit. And we'll talk more about that with the limit test, the nth term test, but they are two different concepts, so we have different vocabulary. Okay. All right, so bounded from above. There is a number m such that that number m is bigger than any output the sequence gives. Okay? That's called an upper bound.
So the opposite of that would be m is less than or equal to a of m. Okay.
I don't know what that means.
Okay, so basically, graphically, you have some number m, and no term of the sequence goes above it. Right.
Okay.
Okay, and we can do the same with bounded from below.
So then do you know if it has an upper bound, do you know that it diverges or converges?
If a
Because-
sequence is bounded from above,
It converges to the bound.
not necessarily.
I was gonna say, because that rule
Not
is still
necessarily.
true if it's diverging from it.
Okay, so no, the answer is no.
Okay.
Can you think of a function that's bounded, or sorry, can you think of a function that has a min, a max that are never across, but it wouldn't diverge?
Sine.
Sine and cosine. 'Cause it is- Yeah, so if I made a sequence sine of n, it's bounded, but does not converge.
Okay.
Okay? It doesn't
What-
diverge either.
I was gonna say, what is that called?
Okay? So it does not converge.
What doesn't diverge?
Are you wrong to say? So dumb.
Okay, so bounded from below if there is. See how this makes you think?
Do we have to do trig in this kind of equations? Will there be
Such
sequences of trig?
That's a silly question. Yeah, of course it is.
He said it.
So is it only sine and cosine that happens, or for things like cosecant and secant, is that still like?
Those are not bounded, they are divergent. Do you know what secant and cosecant look like?
No.
Wouldn't it just be the inverse?
So,
No.
all right, sidebar. Just do this slide. Secant, so sine looks like this. Right?
Right.
Cosecant is the reciprocal. It looks like this.
Oh.
Oh, so just the trials.
So where sine is 0,
Oh.
cosecant is
Okay.
undefined, because you're dividing by 0.
Yeah.
It's moving
The
around.
same thing with cosine and secant.
Okay.
Okay, tangent, where's tangent undefined?
Or sine.
Sine over cosine. Whenever cosine is 0.
Wherever cosine 0,
Yeah.
which happens at pi over 2, the tangent actually looks like this. Okay, funky, huh?
Yeah.
Alright. There you go, sidebar. Okay, a sequence is bounded. Okay, so you got bound from above, upper bound, lower bound, and then generally bounded if it is bounded from above and below. Woo! Good? These are definitions. Finish this statement. If
So, with the general bound, is sine generally bound? Sine and cosine?
it is bounded. They are bounded.
Because they have bounds on top and bottom.
But we're going to talk about that. Finish this statement. If a sequence converges.
Not that. Oh, wait, this is surgery.
For what?
There's grandma's getting a surgery
Based on
for artery clog.
what we just learned from the previous slide, what can you do to finish that statement?
If any converges. Are we talking about the R thing, or can we just do it down?
Just bounding. So if you have a sequence that converges, what can you say about bounding?
It's bounded?
There is a value m that is
Let's just make it easy. We already defined what bounded is, so we don't have to rewrite it. Okay. So if you have a sequence that converges, then it is bounded.
So if it converges, it has to be bounded. But if a series is bounded, it doesn't always have to converge.
The sequence is bounded,
It doesn't always have to converge.
doesn't have to converge.
So it's like.
So what you just stated is called the converse. So this is a statement, correct? If-then statement?
okay.
Okay, the converse of that statement would be this. If a sub n is bounded, then a sub n is convergent.
But that's not true.
Big fat F. So if you have a statement that's true, its converse is not necessarily true. Okay? That is something that's very valuable to learn, especially if you're in like computer science.
Oh, yeah, sure.
Yeah, because you can use those statements, if-then statements, right? Here's something that's really neat though. This is called the contrapositive.
If a of n diverges, then
If a sub n is not bounded,
It's not converged.
then a sub n does not converge. Always true. Contrapositive, if the original statement is true, the contrapositive is always true. But notice how I worded it.
yeah.
I didn't say divergent, I said it does not converge. Okay. So you have to be specific, it's
But how can it
not,
diverge?
then not. Okay, that's a contrapositive. You flip it and you put no in front of both of those.
But it would still work for the if a of n diverges, then a sub n is bounded. Or if you say, when
Okay,
you say
so I think
bounded,
what you're doing is the inverse. If a sub n is not convergent,
But it could be.
then a sub n is not bounded.
no,
Does that have to be true?
no.
So for this converging
No, what are
and
you talking
diverging
about?
business, isn't it just like the right side of the function that we evaluate?
We're looking at positive integers. Is that what you're asking?
Yeah, but as it approaches, as it goes like the right of the graph, right?
Yes.
To the right, yeah. The limit is n approaches infinity.
Yeah, so why does it have to be bounded on both the top and bottoms for it to converge? Can't it just be bounded on top?
It
and
doesn't
still
say
converge?
that.
Yeah, it did. You said,
I said if the sequence converges, then it's bounded.
But if it diverges,
but you
it's
said
still
for,
bounded,
when you're
right?
doing the bounding thing, it said for a sequence to be bounded, it has to have a lower and upper bound.
Uh-huh.
But a series can converge,
Sequence.
sequence can converge without having a lower bound.
Right.
Oh,
They're just contradicted.
no,
But what
because
you have
if
with the
it's
sequence
approaching,
is that we usually define it as the positive numbers only, so as a starting point. And if it has an upper bound, then it automatically has a lower bound too, and is bounded.
because it's converging, so
If
it
it
doesn't
converges.
just drop down, it's always approaching that upper bound. But if it
Start
diverges,
point,
that doesn't necessarily.
If it has an
mean it's
upper
gonna stop.
bound and is convergent, it's convergent, then it's bounded. No matter if it's an upper bound or if you have a different one that has a lower bound. There is always a ceiling or a floor.
Oh, so book, your starting point is your either ceiling or floor.
Right.
Oh, okay.
Yeah.
But that doesn't work for diverges, right?
Correct.
Okay.
Well, a sequence can diverge and still have a lower bound.
Or upper bound.
But if it never,
So you can start and go on up to infinity.
right, but that's
It
not
has a lower
bounded.
bound, but it's not bounded.
Okay.
See the specific wording?
Yeah.
Yeah.
So,
It's not bounded. It is the way it is. Okay.
Is this a real world application type thing, or is this just calc?
Oh, that
Yeah.
question. See, I answered this last time. You know, you asked and I said I didn't have an answer last time. And you weren't here when I answered it.
oh, nice.
So don't be absent tomorrow. I'll try to answer that.
Wait, what was the answer to my last question?
Yes,
Yes.
It was a, why are we doing
the
this?
application of what we were working on is the Taylor series.
Ah,
Oh, yeah.
Level.
the application of
Yeah.
it?
Yeah, I was the same.
Okay, but basically what it does is it makes really complicated equations easy to use.
Oh.
And it makes the computer, if you're using a computer,
Not very
do
good.
a more simple calculation, so it's not using as much computing power
Oh.
if you're a computer scientist, right?
So it's an efficiency.
Yeah, part two.
It's not like
Computer
a,
more
this is the one way to do it.
than
It's more like,
Find better equations.
this is the
Better
better way to do it.
They get that extra gigabyte of RAM.
Okay.
out to create
Do you know what bounded monotonic
Tonic beverage, you know that.
sequences
No.
that bounded on one side?
converge? Do you know what monotonic is?
It's
No.
one something.
Yeah, so you're strictly increasing or strictly decreasing.
True, false, or is it just screwed up?
So it's either going up the whole time or down the whole time. Right? So if you have a bounded sequence that's always increasing, does it converge?
Yes. Yes.
Okay. Bounded sequence that's always decreasing, that converges. Right? Okay. Or, again, bounded sequence that is always increasing.
Wait, they could also diverge.
I was gonna say, wouldn't that be
No,
good?
cannot. Because it's bounded, see?
Oh.
Right, you're saying this is bounded and it is always increasing, has to converge to that upper
What that
bound.
does is that takes away your sine cosine example.
Exactly. Yeah. Yep, you can't float up and down.
Is monotonic something new now? Or is that just like?
How do you show that something is monotonic? with students.
Always.
How do you show,
N plus
B
one is
for
always
F
greater
prime
than
X.
Oh,
Where is it?
you have to use the derivative?
yeah.
Yeah.
So does that mean
this
we
is
have
the
to find
instance
the-
where we have a sequence, let's say something like this.
So then when we derive that,
Okay, change it to a function, because we have to use functions to do derivatives.
okay,
Functions have to be continuous to derive them,
yeah,
correct? So we have to change it to a function, which is legal, it's a theorem. Okay, so what's f prime of x?
natural log n.
Something over n squared.
Because it's X to the negative 1. So it's.
Negative 1 over n. Oh, we gotta put an x there. X there. Okay,
Oh,
What do you think in here?
so how do I show that as strictly
Increasing?
or decreasing? Do a sign analysis, right? Equals 0, never.
That was good.
Okay, right? So that does never equal 0. We have no critical points,
Yeah.
which is what we want.
So it's monotonic.
And then if we do a
It's
f
positive.
prime at 1 sign analysis, we get a
positive.
Oh, that's a negative. Wait, why'd you add a
One
random
square.
negative on this one? Oh, this
a positive.
Oh,
Okay, so we are strictly decreasing, implying that this sequence is convergent. Hold it. Okay, so you might have to use derivatives to show some of this stuff. It's going to be very minimal once we get into these series tests. Okay?
what is the notation in the book for this stuff? Is it like how you wrote it before?
You're seeing it.
Brackets A of n?
So a sub n is the sequence of numbers, so you put it in
Okay.
a set. That's all the numbers possible versus,
And will we ever have to like graph
I mean, you
out
could-
A sub n? Or will most of the questions be if it's converging or diverging?
it's going to be a convergent divergent. Okay. So compartmentalized sequences, because this is all we're going to talk about them. Next, we start series. Series and sequences are related to each other, but they're different.
And you said series
So
is
sequences is the last 2 days worth of learning, 10.1. We move right into series, and that's 10.2 through 10.8, or whatever we do.
And you said series were the sum of the sequences?
Right. It's the sum of the terms of the sequence. So it